Hey, honors chemistry students. I want to go over the limiting reactant problems homework. You can check this to see if you're on the right track on how to do limiting reactant problems. So there are a few critical things that we really need to make sure that we get when we do these problems. So let's go through the first one. Lead 4 oxide. So one of the critical things is that I get the correct chemical equation balanced. So lead 4 oxide ends up being PbO2. Reacts with sodium sulfate, and that would be Na2SO4 to produce sodium oxide, which is Na2O, and lead 4 sulfate, which is that. And then I balance it, and you can see it's already been balanced for you. So that's like if you can't get a correct balance equation, it's very difficult to get the right number answers for any stoichiometry problems. So now let's go through the questions. What is the limiting reactant? So we want to answer that first. And we go to the numbers. You react 100 grams. So there's a start point of sodium sulfate with 50.0 grams of lead 4 oxide. So I'm going to start in both of those, and I'm going to start on the far left side because I know when I do limiting reactant problems, I'm going to have to split one of these columns in half. And you can already kind of see what column I split in half. But let's do the problems anyway. So I want to take each of these down to the carryover X column. And let's start with this one first. PbO2 is 1 lead plus 2 oxygens, big number, 239.20. So 50 divided by that is 0.209. And then divided by 1 is 0.209. So I'm going to stop there on that one, and now I'm going to go to the sodium sulfate and do the same thing. The molar mass is 2 sodiums plus 1 sulfur plus 4 oxygen, so that's 142.05. 100 divided by that gives me 0.704 moles of sodium sulfate. There's a 2 in front of that coefficient, so 0.704 divided by 2 is 0.352. And now I can answer the question. The smaller number between these two columns is the limiting reactant. So down here, answer-wise, LR is PbO2 because 0.209 is a smaller number than 0.352. Question B, how many grams of excess reactant are left over? So now I want to take this smaller number and I want to split the sodium sulfate in half and put the smaller number down here in the carryover line and then take it all the way up to the grams of sodium sulfate. So I'm going to multiply by 2 to get 0.418 moles of sodium sulfate. The molar mass did not change, and that gives me a 59.4. But let's read the question. It says, how many grams of excess reactant are left over? So what that really means is I started with 100 grams of sodium sulfate and the reaction used 59.4 grams. So my answer is not 59.4. My answer is what I started with, 100, minus how much I used, 59.4. So the final answer ends up being 40.6 grams of sodium sulfate. So 100 minus 59.4. The last two questions, how many grams of products did we get? So I'm going to put some stars, asterisks in the grams of each product. And I take that smaller number again, and I put it in the carryover line. I'm just going to take it up, times 2. Gives me 0.418 and then 0.418. Sorry, I kind of had to do this calculation on my calculator because I made an error. So 0.418 times 61.98 gives me a final answer of 25.91. So 0.418 and actually it's 25.9. So sodium oxide 25.9. And then let's do the lead 4 sulfate. So times 1 gives me 0.209. Huge molar mass. 1 lead plus 2 sulfurs plus 8 oxygens from the periodic table, 399.34. So 0.209 times 399.34 gives me that final answer for lead 4 sulfate of 83.5 grams. So make sure you label your answers grams. Bottom question, very similar. First thing I have to get right is a correct balanced equation. So pure copper, that's Cu, reacts with silver nitrate, that's a +1 -1, so that's AgNO3, to form pure silver. So to form, put the arrow, is Ag and copper nitrate, which I've already given to you in the above problem. Balancing that is just a 1, 2, 2, 1, and then a very similar type of problem. You want to make some pure silver. So in the lab, you mix 448 grams of copper. So I know that's one of my start points. I'm going to write that to the far left side of the boxes. And 89.6 grams of silver nitrate. So I got 2 start points. And to answer the first question, what's the limit to reactant? I want to take both of those down to the carryover X line. So start with the copper. Periodic table says it's 63.55 grams per mole. So 448 divided by that, 7.05. There's a 1 in front, so divided by 1, my carryover number is 7.05. Let's go to the silver nitrate. That's 1 silver plus 1 nitrogen plus 3 oxygens to get 169.88 grams per mole. Divide those two numbers to get 0.527. There's a 2 in front, so divide by 2. It gives me a 0.264. So that's pretty easy. What's the smaller number? 0.264. So my limiting reactant is AgNO3 silver nitrate. How many grams of excess reactant are left over? So I'm going to put this dotted line right down the middle of the copper, because copper is the excess reactant. Put the smaller number in the box and take it all the way to the grams of copper. So times 1 is 0.264 times the same molar mass of 63.55 gives me a 16.8. So that's how much copper was used. I started with 448 grams and I used 16.8 grams. The question is how much is left over? So I have to do another calculation outside the table. I need to take 448 minus 16.8. And that will give me the final answer that 431 grams of copper are left over. That is sig fig correct, by the way, if you go back to your rules for subtraction. Then the other two questions, how much silver did we get? That was our main point. We wanted to get a whole bunch of pure silver. And how much copper 2 nitrate did we get? So I'm going to put that smaller number in the carryover and take it all the way to the top. So 0.264 times 2 is 0.528. Molar mass of silver from the periodic table is 107.87 grams per mole. So those two numbers multiplied gives me 57.0 grams of silver. Same thing for the copper 2 nitrate. put it the same low number down at the carryover X row, take it up, multiply those two to get 0.264, and then the molar mass of copper 2 nitrate, that's 1 copper plus 2 nitrogen plus 6 oxygens to get 187.57. Multiply those two to get 49.5 grams of the copper 2 nitrate. That is how you do limiting reactant problems.